Today we'll practice for your formative by solving systems of equations by graphing and then solving by substitution. I'll do the first few with you and then you can try the rest on your own. If you feel confident with graphing and with solving by substitution, then you can fast forward the video where you feel you don't need any help. If you feel like you want step-by-step guidance, then go ahead and follow everything through. Just make sure you're listening to what I'm saying and writing things down at the same time so that you're following along and trying to understand what's happening. You've got to be able to do this on your own. As I look at number 1, I'll start with graphing. The first thing I notice is that neither equation is in graphable form right now. Remember that when we are graphing, we're always looking for a y equals mx plus b equation, right? We're always looking for slope-intercept form. And if they're not given to us that way, then we have to put them in slope-intercept form. I'm going to zoom in on number 1, the equations and the graph, and I'm going to do a little bit of work. I will start with the first equation, which I'll have to move so I have some space to work. If I look at x plus y equals 1, I know that it's my goal, if I want slope-intercept form, to isolate the y. I need to get the y alone so that it looks like this form of an equation. This one should be pretty easy to do. If I make a line down my equal sign, I really only have one thing to do to get y alone. I need to subtract 1x. Remember, there's an invisible 1 right here by the x. There's a 1x. So I'm going to subtract 1 from the left, subtract 1 from the right. I've got y equals, forgot my x there. I've got y equals negative 1x plus 1. Because this was a positive 1, I put a plus here. This was negative 1x, I put negative 1x here. I cannot combine these together because this is an x number and this is a plain number. They're not like terms, so I'm just listing what I have. Now remember, your b, that last number there, is your starting place. Last time we did this, we marked our starting place on the graph with a star. I'm going to go over to the origin. I'm going to go on the y-axis, the up and down axis, and I'm going to go up to positive 1. That is where I will make my star for my starting place. Okay, that's where I'm going to start this line. It's technically a dot, but we used a star last time to build a connection with our star on our equation. Now my slope is an original slope of negative 1 over positive 1. Remember, every whole number is always over a 1 if we need it to be. That slope would have me taking this line down 1, which is the negative direction on your graph, and to the right 1, which is the positive direction on your graph. If you need to mark your graph, please remember to go ahead and do that. The positive direction, the negative direction, the positive direction, and the negative direction. So looking at my slope as a rise over run, I also want to be able to go in the other direction. My line can't only go down, it has to go in both directions from that starting place. So my opposite direction slope would be going up 1, right? Positive 1, basically just taking negative 1 and down and making it into positive 1 and up. and the bottom, the denominator, becomes -1, which goes to the left. I'm going to follow both directions of this slope. I'm going to go back to my starting point, my 1. This is sort of like my new origin for this particular line. And I'm going to start counting down and to the right, like my original slope says. So I'm going to go down 1 and to the right 1, make a dot there, down 1 and to the right 1. A slope of 1 is a perfect diagonal on the graph paper. It's a really nice slope to have. So I'm going to keep going pretty far. Then I need to go back to my starting point again. And I've got to start working in the other direction. That's why we do this opposite thing. I also want my line to go up this way. So I'm going to start going up and to the left, up 1 and to the left, up 1 and to the left. And I can kind of keep following that pattern. Now I'll connect those lines to make my, connect those dots, excuse me, to make my line. And I've got the first equation done. My second equation is going to require some space as well. So I might have to use some space, some paper off to the right. Oops. I'm going to choose a new color for that equation. I'll choose purple. I'm going to take this equation and use a little bit of space over here. I've got an equation that says x minus y equals 7. So I've got to do the same thing as I did before. I've got to isolate the y. This is going to take more than one step. I can already preview this. First thing I'm going to do is subtract that 1x, just like I did earlier, from both sides. Now over here, I'm left with negative y equals negative 1x plus 7. Again, I had a positive 7. There is an invisible 1 in front of the y. Now, if it were a positive 1, it wouldn't change anything, and we can just leave it alone. But this is a negative 1, which means, number 1, I've got to get rid of it. I've got to cancel it out over there. It also means when I divide by negative 1 for my x, and I divide by negative 1 and my 7, it's going to change all of this. Y equals 1x minus 7. So here, for this particular line, I've got a starting point of negative 7. Probably should do that in purple. So I'm going to go over to my origin, and I'm going to count down to negative 7, and I'm going to make my star there. Here's my star for negative 7. I'll make that star over here. And then from there, I'm going to follow my slope and go up 1 and to the right 1. How did I know that? Well, my original slope was positive 1 over positive 1, right? I've got a positive 1, and I can put that on top of another positive 1. That has me going up and to the right. I also need to create an opposite slope, which would be going down 1 and to the left. So it looks like we're going up is going to be the most helpful to cross the other line. So I'm going back to my starting point, and I'm going to go up 1 and to the right, make a dot. Oops, that was off. Up 1 and to the right, 1 and to the right. And it looks like there's my crossing point. I'm going to keep going with my dots a little bit because, you know, I like to make those nice lines. I like to connect the dots nicely. But I'm not doing a very good job with my stylus here. Ay, ay, ay. All right, I can connect those dots. And now the last step is that I have to identify where is this particular point where they meet. So remember your XY coordinate pair, that's your answer. Your X number tells you from the origin how far left or right you need to go to get to that point. And your Y number tells you how far up or down you need to go. If we go back here, it looks like to get to our point, we're going to go over +1, +2, +3, +4. So as I prepare my final answer, I'll have a +4 in the X. And then I need to go from there, from that +4, I'm going to go down -1, -2, -3. My answer to this problem should be 4, -3. And that's how you solve by graphing. Okay, so I've moved over to substitution. I'm going to solve the same problem, so we should get the same answer, but I'm going to use the strategy of substitution. I know that for substitution, my goal is that I need an x equals or y equals equation, right? I need something to tell me what x is equal to or what y is equal to. I need to, looking at these two equations that I'm given, neither of these gives me any information I can substitute. I don't know exactly what y is equal to, and I don't know exactly what x is equal to. The cool part about this is I get to decide whether I'm going to isolate x, isolate y, what I'm going to do. It's up to you. What I do is I look for the easiest thing to isolate. It seems like for each of these, it's pretty easy to isolate the x or the y in each of them because there's nothing being multiplied by x or y. Well, there's a -1 here. I think what I'm going to do is take this bottom equation. I'd like to actually get rid of this -y. Why not get rid of a negative if we can? I'm going to add y to both sides. Now I've got an equation that says x is equal to 7 plus y. This is going to be my new second equation. I'm going to kind of cross that one out. This equation gives me more information. It's the same thing, it's just rearranged so that I know exactly what 7 is equal to, and I know what I can replace in the other equation in the place of my x. Now this is one of those ones that can be so easy that we can make it harder than it is. What I've got to do is take this equation over here. I've got to replace my x with the information inside the parentheses. Because there's no number here for me to multiply by, I really can just put this stuff right into my new equation. I can put 7 plus y, which stands in for my x, plus y equals 1. What I've written in purple is the stuff I've substituted for the x, and what I've written in black is the information that was in the equation to begin with. Now I get to start solving and calculate my y. So I notice I've got 2y here. I've got 1y plus 1y equals 2y. It's a positive 2y, and then I've got 7 to bring down. That's all equal to 1. I'm going to subtract 7 from both sides because this is a positive 7 at the beginning of the equation. Two y is equal to 1 minus 7, which is negative 6. Divide by 2. And y is equal to negative 3. That's the same y that I got when I was graphing, so far we're on the right track. In my xy coordinate pair, what I need to do now is calculate the x value, which I can do by looking right at this equation. This equation tells me if I take 7 and add it to my y number, I can calculate my x. So I'm going to take that equation that's in the rectangle above and just kind of copy it. I'm going to put parentheses around the y. That's what I'm going to substitute because that's what I now know. It's my new information. X equals 7 plus negative 3. Which means x is equal to 4. I'm going to put that answer in right over here. I'm going to put a cloud to kind of signify my final answer. And what we have just done is solved the same equation two ways, once by graphing and once by substitution. We got the same answer, so that means our work was correct in both areas.